Hi there, Math 30-2 group, and we're on lesson 4 here. Let's find out what we're going to be learning here by rational expressions and rational equations. We'll look into that more in this topic. We'll also look at the 4 operations for rational expressions and then investigate non-permissible values. And keep in mind, non-permissible values is another way of saying NPV, the abbreviations of that, and solve rational equations. With all that in a nutshell, we can actually solve real-world problems with that. So let's get going here and let's take a look at what a rational number is all about. So it's basically a fraction that can be written with any two variables that are different. C over D is the one I used. And then a numerator C and a non-zero denominator D. So that means this D cannot be 0. Since D may be equal to 1, every integer is a rational number. And the same thing goes for whole numbers too. So why can't you have the denominator be 0? One of the things that you learned back in the day in elementary, if you had 3 divided by 2, we would say to students how many 3's could go into 2. And then, of course, you'll realize it's not a whole number, it's 0.6 recurring. What happened if we said how many 3's could go into 0? It's not possible. This is why if you type it in your calculator, it should say something that astonishes you because it says undefined. So we cannot have any amount into 0 because it doesn't exist. So this is not possible. So keep in mind, rational numbers versus irrational numbers, a little bit different. The rational numbers are dealing with anything that actually are like integers and natural numbers, or another way of saying that's whole numbers. And rational numbers can also be classified as the following, as a fraction or as a decimal. Here's another example, 2125. So that means it stops there. So that basically shows that it's a rational number. Negative 1.7, it stops, it terminates at 7. 7.66, this number keeps going, but we know the pattern. If you know the pattern of it, it's still considered a rational number, such as 2.1515, another way of writing it with these dots. Representing 1.5 is going to be repeated. So in an example of irrational number, like the following examples, they do not have a pattern in any sense and they keep going forever. All of these are examples of real numbers. Hence the fact you might see the real number to represent as an R. So in domain and range later on, you'll learn in the next lesson, we would usually say X is the elements of the real numbers, and that's where we actually show X is the elements. Elements we learned that funky E back in lesson 1 of the real numbers. Anyways, off topic there. So why do math teachers ask students to solve equations? It's essential to know that any world problems can be always written as an equation, and you're going to have to solve them, usually in business in that sense. So it's good to know, get familiar how to do equations, of course, and how to solve them. So we have 2 of them right here. I'm going to focus on the left one here. If you have a variable on the left-hand side and the right-hand side, and then a constant of 5, you want to isolate one of the variables. Well, right now we have 2 of them. Rule of thumb is always get the smallest one out of there. So negative x. I did negative because this is saying plus x right now, so that's the opposite of that. That crosses out, and then we are left over with 0 equals to 5 plus 2x. Are we done there? No, because we still haven't isolated the right-hand side. So move the 5 by doing negative 5, negative 5. And now we're at negative 5 equals to 2x. Now we need to divide both by 2. And then our final answer will be x equals to negative 5 over 2. I prefer to leave it as a fraction, but some students like to take the next step of writing that as a decimal, and this would be the decimal for that case. So we can consider that to be a rational number. Over here, you will realize we have a variable only on the left-hand side, but it's in fraction. And there's another fraction over here too. So one of the things that teachers have taught in the past is cross multiply and then divide if need be. And in this case, we will be. So 3 times 6, and that's going to equal to 5 times 2x. I'm going to put that in the bracket. And 18 equals to 10x. Now we just divide by 10 on both sides. And now we get the right-hand side to be 1.8 as a decimal, or that's about x by the way, or it can also equal to, reduce that fraction, 9 over 5. Looking at the next one here, what we have is a bracket, and we always want to expand these brackets. So we have to use FOIL, and what's going to happen here is nothing else has to be expanded. So we rewrite 25b minus 7 equals to 43b plus 8b minus 8. Okay, so can we collect any like terms? We can. Here's a like term, and at the same time we want to move this over and move this over also because that's the lowest one. So minus 25b, the same time, plus 8. Get rid of this one, and we can collect those. So we're going to do minus 25b and minus 8 for this one. That cancels out. And then we're left over here. That cancels out 2. So we get positive 1 equals to, well, 23 plus 8 is 51. Taken away from 25 is 26b. And now we have to divide by 26 on both sides. And then we get b equals to 1 over 26. As I said earlier, they leave it as a fraction. You really want to go to the next step, type it in your calculator, and you'll see there's a pattern associated with it. Moving on to the next one. There's 2 brackets here, but this bracket wasn't even needed because there's no number in front. So we don't even have to expand that bracket because there's really 1 right now for that. So you get 2x plus 2 equals to 1 minus x plus 3. Now what we need to do from here is, of course, collecting the like terms. The x is cancelled out on the right hand side, and then we have 4 on the right hand side because 1 plus 3, and we have 2x plus 2. Okay, so you want to isolate the x on the left hand side. So what we're going to have here now is 2x equals to 2. And now we want to divide by 2 on both sides. We get x equals to 1. One way you always should be doing anytime you solve it is actually substitute the numbers back in there and check if it's actually true. So 1 could go back into here, go back into here, and go back into here. And then ask yourself, 1 plus 1 is 2, 2 times 2 is 4. So the left-hand side has to be 4, the right-hand side has to be 4. 1 minus 1 is 0. 1 plus 3 is 4. Yes, indeed, it is 4. So you've checked. It is great. You can do the same thing for any other problem. When we need to solve also in this course, polynomials. Typical polynomials we can have is common factor ones, like the following. So what's going to happen is that you need to ask yourself, is there anything common with the first term, second term, and third term? There are, the x and the 2. So I will actually literally put the 2x outside and make a bracket now, because we're going to multiply that with all of these to make that. But we're basically dividing right now. So 2 divided by 2 is 1, and that leaves us with 1x left to an exponent of 2. Next one, 6 divided by 2 is 3, and x squared divided by x is x, and 4 divided by 2 is, as we know, 2, and then the x times x would make the x, so we're not going to include it. Okay, so that's common factors, how we're factored out the following. We're not just done, but I have to explain the concept right next to that. So grouping methods is another method that is straightforward, where we have to understand that if there are 2 terms that look the same, like this one and this one, we need to collect them as a group. So that means we're going to have 2x minus 1 as one, and then x minus 4 as the other. And both of those are going to equal to 3. Now here's the bit where we need to take the next step further for this, where we would need to do 2x minus 1 equals to 3, or x minus 4 equals to 3. As we know, we would have to add 1 on both sides for this one. Then we get 2x. This cancels out, equals to 4, divide by 2, divide by 2, x equals to 2. That's one solution. The other solution would be add 4 on both sides, and then you get x equals to 7. Those are your two solutions for that. Another method of solving, factoring, is by sum product pattern. What do I mean by that? Well, if we have a product, well, we have 3 problems to deal with. Let's just tackle one at a time. The last number is the product we need to find out to make this possible. Anytime this is square, we're going to have 2 brackets. So what are the factors of 12? 12 and 1, 2 and 6, 3 and 4. Anything else? Nope. So now, what are the 2 numbers that you need to add together to make the middle number, 7? We will discover that it's this one right here. So what's going to happen is that we're going to have 2 brackets, and both of those are going to equal to 0. So x plus 3 and x plus 4 would be the 2 factors. Now you have to make them to equal to 0, so x plus 3, and then x plus 4. You will realize that you have to subtract 3 on both sides, subtract 4 on both sides. Our final solution here is minus 3 and minus 4. Those are the 2 solutions. So going back to the first one earlier, what would be the final answer for this one? And we factored it. You will realize that the only factor for 2 is 2 and 1. So that would mean 2x equals to x plus 1 plus 2 equal to 0. Now we have 3 in this case because of this one in front, 2. So what's going to happen is you put 2x equals to 0, x plus 2 equal to 0, and x plus 1 equal to 0. So divide by 2, both sides, you'll realize 0 divided by 2 is possible, which is 0. Next one is minus 2 on both sides, negative 2. And the last one, plus a negative 1 on both sides, negative 1. There are 3 solutions for that. So if we keep going down to this one now, the same thing like earlier, but now be careful. Because the right-hand term on the right-hand side is negative 2, you want to make that equal to 0. So I'm going to add 2 on both sides. That's the first step. X squared minus 13x plus 42 equals to 0. Now, like we did earlier, list all the terms of 42, 142, 2 and 20. Oh, we want to do 42 divided by 2, 21. Okay, 3 could go into 42. And I want to say it's 13. It's or higher, I think 14. Divide 42 divided by 3. Yeah, 14. Okay, so 3 and 14. And 4 doesn't go into it. 5 doesn't go in it. 6 and 7 would be the last ones. Okay, now in this case, because one's negative, one's positive, that means the 2 products, when you multiply them both together, they have to be negative. So now, is there any solution here that when you add them both together, Negative 6 plus negative 7, negative 3 plus negative 14 makes negative 13. You'll realize that negative 6 and negative 7 are the ones for this. So that means x minus 6 and x minus 7 are your solutions. That equals 0. So you have to do one more step, of course. Add 6 and add 7. Your two solutions are 6, 7. In this case, you have to do the same thing as earlier. Minus 5x minus 5x. Remember, the right-hand side is preferable to be 0. This is your 0 now. 24 doesn't change. 7x minus 5x is 2x. And then we have an x squared. Okay, in this case, we're going to be realizing one's going to be positive, one's going to be negative. But we still need to list off the factors of 24. 24 and 1, 12, and 2, 3 and 8, 4 and 6, and that is all. Okay, so one has to be negative, one has to be positive. Now keep in mind, negative 24 and 1, you can know right off the bat won't make 2x. 12 and 2 won't make 2x. 3 and 8, not possible, but now this one would be the key. But now which one has to be negative, which has to have positive? So the positive value is plus 2x, so it has to be a higher value for that one. So negative 4 times 6 is negative 24. Negative 4 plus 6 makes positive 2. So that means x minus 4 is one solution. X plus 6 is the other solution. Of course, those both equal to 0. And now you have to just work out what that's going to be. X has to be 4 and negative 6. One more concept that we should learn is difference of squares. Now keep in mind, difference of squares, as the term says, there's squares involved in here. And one of the things that you're going to be looking at is all squares are basically any number that you multiply by itself, like 1 squared, 2 squared, 3 squared, 4 squared, and so forth. And 5 squared is 25, and so forth. So like we did earlier, we always want to make the right-hand side to be 0. So what we left over on this case is minus 9 equal to 0. Now, to make this work, you're going to realize if this number is a perfect square and it's with negative and it's a square, right off the bat, you're going to have two brackets. Both are going to be starting with x, of course. One's going to be positive, one's going to be negative. So now you ask yourself, what square goes into 9? 3. And that works out nicely. If you don't believe me, FOIL that out. Are we done? No. We have to say x equals to negative 3 and positive 3. Negative 3 comes from here, positive 3 comes from this one. In this case, is there any grouping that is common here? Of course, divide by 2, so factor out the 2. So x squared minus 36 equals to 0. Now you're just focusing in the bracket 1. Okay, so 2 brackets, both equal to 0. So what's going to happen now is x. Now you ask yourself, which one is it? 6 times 6 is the key here. Plus 6, 2. So what's going to happen here is x minus 6 equal to 0, or x plus 6 equals to 0. Now the 2 that has nothing associated in it's just a constant or a coefficient in this case, so it does not play a factor. So what's going to happen here is x equals to 6, comma, negative 6. Difference of squares, always with difference. This is where that's coming from, and square number is where this number is coming from, or right over here. And then you always have the same pattern. Let's move on here. What is an LCD and LCM? Well, lowest common multiple, and then the other one is lowest common denominator. Two different things. And how they work, well, if you wanted to find the lowest common multiple of any value, let's just say it was 3 and 5, what is the LCM of these? You list them off. 3, 6, 9, 12, 15, so forth. Same thing for 5. 5, 10, 15. And you'll find that the LCM is 15. It's 3 and 5. So in lowest common denominator, this is dealing with fractions because denominator means the bottom of the fraction. And if you had 3 over 4 and you wanted to find the lowest common denominator of 2 over 6, now you need to do the same thing as we did earlier, find the lowest common multiple of these two values. So that would be 4, 8, 12, 18, dot, dot, dot. And then for the 6, we have 6, 12. 6 times 3 is 18, and so forth. And then we realize 12 is the lowest common multiple. So that really helps us because if we have to add and subtract any fractions, we would have to make the denominator the same and then change the tops of what you did here. So we would have to times this by 3, times this by 2, same thing on top, same thing on top, to make them equivalent with the lowest common denominator. To find the lowest common denominator, you need to know how to find the lowest common multiple. Moving on here, so if you needed to add and subtract fractions, you would follow along with the steps that I just did above the left-hand side here. So if we took another example here, actually we can just take the example we just did. 3 over 4, let's add it to 2 over 6. We just said the lowest common multiple is 12, and we multiplied by 3, multiplied by 3, multiplied by 2, by 2 to make that possible. 6 times 6 is 9, plus 4, and you're going to realize you get 15 over 12. Now, this can be reduced. Both are in the 3 times table. So that's 5 over 3. 3 times table, so that should be 4 then. Now, there's one more thing you can change is to make this a mixed number. So you need to ask yourself how many 4s go into 5. Well, 1. And then what is the remaining to make it 5? 4 times 1, make 5. You can have it in 2 different formats, just giving you a heads up. So the same thing happens if you subtract. And we'll quickly do the same, another example here. 2 over 3 minus, let's say 1 over 5. We said earlier 3 and 5 is 15, so we could just go directly into that one. 15, we found the lowest common denominator. So we need 2 times by 5 for this one, and then times by 3 for this one. And then we get 10 minus 3, which is 7 over 15. We can't reduce that any further. So just giving you a heads up, this is how we do fractions with adding and subtraction. So what happens if we want to multiply and divide fractions? Let's look at the first one here. Anytime we want to multiply fractions, we just multiply the top with the top, numerator with numerator, denominator with denominator. So you can rewrite that as saying 4 times 6, 3a. I'm going to put in bracket because every time they're available, not to confuse anything else. So you get 21a over 24. Now you can reduce that because both are in the 3 times table. 7 over 8. Don't forget to include the a. So in dividing, a little bit different. So what's going to happen is that you're going to find the reciprocal, which is flipping the denominator with the numerator, the second one, and changing this into a multiplication sign. So to rewrite that, we want to write it as 5 over 7c, that didn't change, times this as 12 over 8, and do what we just did earlier. So that means 5 times 12 is 60 over 7 times 8, 56. C. Now, ask yourself, is there anything common with both of them? I know right off the top of my head, they're both in the 2 times table. So that's 30, and this is over 28. C. Now I could divide it one more time, 15 over 14. And this is C. There's one more thing we need to do. Like we said earlier, denominator can never be 0. So this is when we list off an NPV. So this means C cannot be 0. If it was 14 times 0, then this will not be a true statement, meaning that it will not be possible. So we will learn more about NPVs in this unit. Another thing we need to focus on is converting minutes to seconds and hours to seconds. So if we have 3 minutes and we need to put that into seconds, first things first, you need to understand there's 60 seconds in a minute, so times that by 60, and then you're going to realize that 3 times 6 is 18, and another 0, so that's how many seconds there are. What happens if you want to convert 54 seconds into minutes? Well, we know it's very close to a minute, so what we need to do is divide by 60 in this case. We go the other way around. And 54 divided by 60 gives us a 0.9 of an answer. And that's a minute. But now, what we're going to be realizing that it's not 0.9 minutes in the sense of saying, well, it's another way of writing that is 9/10 of a minute. Keep that in mind because you would actually times that by 60 to figure out that was actually 54 seconds. So what happens if we wanted to find how many hours are into seconds? So prime example, 3 hours into seconds. Well, key thing is that there is 60 minutes in an hour and 60 seconds in a minute. So 60 times 60 gives us 3,600 of that magic number that we're going to use. So 3,600. So 36 times 3. Top of my head, I do not know that, which gives us 108. Now, don't forget to add the 2 zeros in 10,800 seconds. So that's one of the things that we'll have to go back and forth. The reason why we're doing that, because back in grade 8, you did velocity time questions, or speed time questions, and we learned that distance equals to speed times time. So what's going to happen is now we're going to take problems and actually focus on using that, and you might have to convert from minutes to seconds and so forth. So prime example, if you ran at a speed of 11 kilometers per hour for 40 minutes, how far would you run? Well, first things first, this is in minutes, so we need to convert that to hours to make our life easier to actually convert, then to multiply and so forth to figure out how far we actually ran. So how many minutes are in an hour? We said 60, so we just have to times that by 60. 6 times 4 is 24. With the 2 zeros in, gives us that many seconds. But we wanted to go to minutes to hours, so that's not going to help us. We should divide it by. Okay. So 40 divided by 60 gives us 2/3, 0.6 recurring of an hour. Now we could use the following formula. We know the speed, we know the hours now. That will now give us the solution. 7.3 recurring, and that is how many kilometers it traveled. 0.3 of a kilometer, and then 7 kilometers of that. So you're going to be dealing with questions like that too. And always remember the units have to be the same. Let's finish off with a prayer here. May the Father, Son, Holy Spirit, Lord, we thank you 100-fold for infinite love and care that you have given us. May we in return multiply it with love and respect and more faith. Subtract the worldly desires and all evil works in our minds and hearts. Divide your given talents to all of us. To sum it all, may we be united as one in your family. Amen. If there's any other questions, don't hesitate to let me know. Have a great term.